Hi everybody, welcome to the last part of 7.1 dilations. Today we're continuing with drawing dilations in the coordinate plane. Now we're looking at composition of dilations, which means one dilation after the other. Okay, so let's look at this. Graph QRST and its images after a composition of dilations centered at the origin with a scale factor of 2 and a scale factor 1.5. Given that Q is 1, 1, R is 1, 3, S 3, 3, T 4, 1. So we have two scale factors, okay, 2 and 1.5. Since the origin or the center is the origin, this is easy. You just, for the first dilation, you multiply each x and y by 2. So 1, 1 becomes 2, 2, 1, 3 becomes 2, 6, and so forth. And that's how you get RST, R prime, S prime, T prime, Q prime. Okay? And then for the second dilation, again, you multiply these with 1.5. Okay? So 2, 2 times 1.5 is 3, 3, 2, 6 times 1.5 is 3, 9, and so forth. And now you get the second dilation. Okay? So you repeat the process twice of multiplying the coordinates of each point by the first scale factor and the second scale factor. Let's do an example similar to this. For the first exercise, graph each figure and its images after the indicated transformations with the given center. So for 4a, we have a triangle with dilation 2 and dilation 1 over 3 and a center of 0, 0, which is the origin. Let me just draw the triangle. So this is our triangle. For the first dilation, we take the points of the original triangle, A, B, C. A is minus 5, 2. B is minus 1, A. And C is 2, 4. Now, for K equals 2. So we multiply everything by 2. Minus 10, 4, minus 2, 16, and then 4, 8. And then another dilation, K equals 1.5. Again, you multiply these now. So A double prime by 1.5 minus 15, 6, minus 3, 9, and then 4 times 1.5 is 6, 12. Alright? And then you plot the points on the graph. So for these points, some of them, the numbers are just too big, like this and this. So they're not going to fit on this graph paper, but you get the idea. Okay? Just, plot these points on the graph, wherever they are, and then connect them to get the first dilated triangle and then the second dilated triangle. Alright, now we're going to move on for the second exercise. Now for the second exercise, we have this rectangle JKLM with dilation of a half, and then the second dilation is not a scale factor, it's just a reflection across the x-axis, which is, it's not that hard. Let's start with the first dilation. Okay, so because the center is not the origin, this time we do it differently, as you might remember. So from center C to J, how do we go from C to J? We go down 1 and then left 3. Okay, now when you multiply by a half, so we're going to go down 0.5 and then 1.5. Okay, now from C to M, we're going down 1 and then left 1, 2, 3, 4, 5. So multiply everything by a half, 0.5, 2.5. And then from C to K, we're going up 4 and then left 5. Multiply that by half, so we're going up 2 and then left 2.5. Last one, from C to L, sorry, right here we're not going from C to K, we're going left just 3, so will be 1.5. Okay, now from C to L, we're going up 4 and then left, this one is 5. So this will be 4 times half is 2 and this is 2.5. Alright, let me plot these points. Now for the dilated, for the first dilation, we're going down half and then left 1.5. Okay, and then for the second point, going down half and then left 2.5, which is right here. Now for this one, we're going up 2 and then left 1.5, and for the last one, we're going up 2 and then left 2.5. Let me just connect the points. So this is our first dilated figure. Now for the second dilation, we're just doing reflection across the x-axis. Okay, so each point we're going to change the y value for it because it's reflected across the x-axis. So if this is minus 1.5, if this is 1.5 for y, it will be minus 1.5. So this point will be right here, and this point will be right here, these two. Now for this one, right here, and for this last one, it will be right here. Let me just connect the points. Okay, that's it. So this would be K prime, L prime, and this is J prime, and right here is M prime, space, and this one will be J double prime, which is the reflection of this across the x-axis, and this will be K double prime. and this will be L double prime, okay, and this will be M double prime, okay. So each point, to do a reflection across when you do reflection across the x-axis, each y, you take the opposite of it. For example, right here it was 4, it becomes minus 4. Okay, this one was 1.5, it becomes minus 1.5. Okay, the x's stay the same, but the y's are reversed. Well, that's it for today. So let's recap. What we did was do transformations with 2 dilations. All right. For now, for the first, if the center was the origin, you just repeat the process twice for the first dilation and for the second dilation. Okay, you multiply the coordinates of each point by the first factor, and then what you get, you multiply that again by the second factor. Okay. Now, when the center is not the origin, it's a little bit different, but you know, it's done. We've done that before. You look at the movement from the center to each point, and then you multiply the number of units that you move by the first scale factor, and then you repeat that for the second scale factor. Now, this example, the last example we didn't have 2 scale factors. We had 1 scale factor and a reflection across the x-axis. When you reflect an image across the x-axis, the x coordinates stay the same, but the y coordinates are reversed. So if they're positive, they become negative. If they're negative, they become positive. If you were doing reflection across the y-axis, the y stays the same and the x's are reversed. So if x is positive, it becomes negative. If it's negative, it becomes positive. Alright, I hope you stay safe. Please subscribe, leave some comments, and let me know how you think about those videos. Alright, bye bye for now.